In this video, we'll be talking about the properties of a rectangle and how that deals with their diagonals. So here we have a rectangle. We can see that it moves around, changes different sides. So if we add in the diagonals, we're going to ask the question, are these diagonals perpendicular bisectors? Well, what is a perpendicular bisector? A perpendicular bisector is a line that intersects another line so that it is not only at the middle, but it also is the perpendicular. So no matter what the length of the line is, it will always be at the midpoint, and it will be at a right angle to that original line. So we want to know, are these two lines perpendicular bisectors? Well, if we go back to our perpendicular bisectors, we need to ask ourselves, how do we construct such a thing? We can use two circles and then join the points where the two circles intersect, and we have a perpendicular line that not only meets at the midpoint, no matter where it is, but also is at a right angle. So then if we go back to this shape, if this is a perpendicular line to the segment HE, then it should be at 90 degrees and be at the midpoint. Well, if we just draw our two circles again, and then we connect where the two circles meet, this line should be 90 degrees. It is 90 degrees and at the midpoint. So we notice that the point of all these three lines meet at one point. However, when we change the shape of the rectangle, it is not always at 90 degrees. However, there is an instance where the perpendicular bisector is the same as FG, is along the same line. But if we change the shape just a little bit more, it changes. So then, let's talk about what is this shape right here. Well, if this is 90 degrees, then we know that these two must be 45 degrees. So if we have 45 degrees, 90 degrees, and 45 again, that creates an isosceles triangle where these two sides are the same length. But the special property about an isosceles triangle is that if you put two of them together, then we have this length, this full length, being 90 degrees, because 45 plus 45 is 90. So if this is 90 degrees, and this is 180 degrees, so if we look at this triangle right here, we notice we have a 90 degree up here, we have two 45s, and that means that each side is 90 degrees. So if we do the same thing over here, we have four sides that are 90 degrees. That's not the only property that we have. We notice that since all these triangles, this triangle, this triangle, and this triangle, and this triangle are all similar, we have that all these sides are equal. Namely, we have a square. So, the only time that a rectangle has the diagonals as perpendicular bisectors is when the shape is a square. Another question we could ask is, what is the angles of these two shapes, of these two? So this one and this one. Are they similar? Are they the same? Well, if we look at another rectangle, we notice that as we change here, we have it mapped out that DBA, so DBA, and ABC, ABC, so this angle and this angle are marked over here. If we notice that they are both not the same number, in fact change quite a bit, but they both do add up to 90, as we have DBA plus ABC is 90 degrees. So they do not bisect the angle because they are not the same, where a bisection of an angle is having the angle being split into two parts. In fact, the only time that it is an angle bisector is when it is a square. So when it's a square, we have these two that intersect this angle and this angle being equal. Well, we know if these are equal, then their opposite sides have to be equal lengths as well. And we know that in a square, these will be 90 degrees. So if these are 90 degrees, then this is also 45 degrees, and this is also 45 degrees. That's making these the same length. And if this side and this side are the same length, that means it is the same length of this side and this side. So therefore, if this is 45 degrees or an angle bisector, then the whole object has to be a square. Now let's talk about different shapes that are not squares or rectangles. Let's go to a parallelogram. What makes a parallelogram a parallelogram? Well, a parallelogram is also defined as a quadrilateral. A quadrilateral is 4 sides. A parallelogram is a specific kind of quadrilateral where it has 2 sides. The opposite 2 sides are parallel. So this side and this side are parallel, and this side are parallel. How do we know that they're parallel? Well, simple using geometry sketchpad is we can select a line, can select a point, and construct a parallel line. And we notice that is the same line no matter how we move it, they are always parallel. And then we can select another line and another point and say construct a parallel line, and we get another parallel line along same way it is parallel. So, what are some properties? We have 2 sides that are parallel. Now let's talk about their perpendiculars. We want to know, are these not only angle bisectors, but are they perpendicular bisectors? Well, just by looking at this, it kind of looks like they're perpendicular bisectors, but let's draw our circles just to make sure. So we make 2 circles, and then we join their centers, their meeting points, and we notice that no matter how much we move it, as long as it stays parallel, then we have that it is indeed a perpendicular bisector. How about these angle bisectors? Well, there's a simple way is we can just pick an angle and measure it. So we have that ABC is 64 degrees, and now let's look at CBD, and notice it's also 64 degrees. And as we change this, it is indeed the same angle. Now let's look at BDA. 17 degrees. How about CDA? 17 degrees as well. So we notice no matter how much we change it, those angles are always equal. So therefore, this is indeed they are indeed equal. Oh, come on. Oh, alright. Done with you. Now let's look at another shape. Let's look at a trapezoid. And namely, this is an isosceles trapezoid. What makes an isosceles trapezoid a trapezoid and isosceles trapezoid are 2 things. One, you have these 2 being parallel lines, and the feet, as they call it, this length and this length, those have to be the same length. Well, how do we find out if they're same length? Using circles, we can see that this length is equal to the radius of these two circles, so these two are equal. And if we look at this circle, we notice that this length and this length are equal, so therefore this length and this length, they are both equal. Oh. So it's an isosceles trapezoid. Some conjecture could make it maybe we have angle bisectors, so let's see if that is correct. Well, I mean, these seem kind of close to 90 degrees, but if we notice as we adjust the shape, it doesn't really look like they're 90 degrees, but let's test just to make sure. We'll make it a little bit smaller, just so it's easier to see. And we will make... And we notice that it's really far off from the perpendicular bisector. So the diagonals are not perpendicular bisectors. In fact, it looks almost like this is in between. So these two are equal. Let's see. We can use the same strategy. We'll make a point along these two lines. And we'll see as it adjusts, it kind of doesn't move. And we'll see if we make a circle here and a circle here, if these 2 points intersect that point. See, now it would be the midpoint, but as it moves, so does this dot, so therefore this point is not the middle of that line.